Okay, so welcome to the new series or the playlist on the channel, which is the next unit, polynomial equations. Not functions, but polynomial equations, which is a much more like algebraic side of the functions because they're really connected, except this one's more focused on like, some of the algebra behind it and like the theorems that we're going to learn about. So the first one that the first theorem that we're gonna look at is the remainder theorem, and it seems silly, except you're actually gonna need to know how to long divide in this. So it's good to just practice the easy, simple stuff like that. Like for example, dividing 534 by 7. So we're actually gonna have to know how to do stuff like this. So let's take a look and let's do 7. We know that 7's what's going to be divided by, so it's on the outside. And then 534 is on the inside of here. So we know that 7 goes into 5 0 times, so we're not going to put anything over top of the 5, so nothing there. Then we got 7 goes into 53. How many times does 7 go into 53? And that would be 7 times, and it would be 49. So put the 7 over top of the 3. And then we'll write the 49 down here. And then you remember that you subtract these two. So 53 minus 49 is 4. And then we're going to bring down the 4. And then 7 goes into 44 how many times? And that would be 6 times. And it goes at 7 times 6 is 42. So 42 minus, and then 2. And then you can't really do anything else. If you wanted to, you could add a decimal and then start going to how many decimal places it would be. But we're gonna just say that this here, the 2, is our remainder. So whatever you're left with at the bottom is the remainder. Okay, so now that we know how to long divide again, just a little refresher, we're gonna take a look at the next part. So in order to do the remainder theorem, you kind of have to understand these different forms of writing things, because on like a test or something, they could very much likely ask you to write that long division statement as a division statement, or write that long division as in quotient form, like your answer. So in order to do that, we need to know what these mean. P of x is a polynomial. Q of x is the quotient, r is the remainder, and x minus b is the divisor. So what does that mean? P of x, we know that a polynomial is just, something that's like x cubed plus x squared plus x, something like that. The quotient is going to be the answer, because, if you have 64 divided by 8, the quotient would be 8. And then the remainder, we classified in the last slide, is that's what number that you're left with. And then x minus b, the divisor, is what you're dividing the number by. So if we look back at the other one, we know that the divisor for this one would be 7. And then the p of x would be 534. The remainder is 2. And then the quotient would be 76. So okay, we're done with that now. So now, how can we write these in quotient form and a division statement? So in quotient form, it's going to be written as P of x divided by x minus b will be equal to Q of x plus the remainder divided by the divisor. So that would be in quotient form. And then if we wanted to write that with the answers from the last one, so we know that our P of x would be 534. 534 divided by, and then 7 was going to be the divisor. And then Q of x is the quotient, our answer was 76, plus the remainder. We know our remainder was 2, and our divisor was 7. So that's how you would write it as in quotient form, the answer. And of course, these really aren't polynomials, and these aren't, I guess it could technically be a divisor. But in like the examples that we're going to get to, we're going to be dividing like actual polynomials with like, you know, x values. So that's why it might look a little bit weird and confusing right now. So next one, the division statement. We know that this one is going to be x minus b times q of x, the quotient. Or wait, that shouldn't be in brackets, my bad. X minus b times q of x, and that's going to be plus the remainder will be equal to the polynomial. So for this one, we know x minus b, the divisor was 7, so 7 times q of x, our answer, the quotient, was 76, plus the remainder, we know the remainder was 2, will be equal to 534, because that was the polynomial. So, well, if you really want to check that, you could, just to double check, you could multiply these two out, add 2, and you would get 534 equals 534. But now, moving on. So how can we do this with, you know, how can we do this with the hard stuff? Like, how can we divide something like, how can we divide something with like random unknown values like 3w minus 2 and divide it by a polynomial like 9w cubed, 2w, and a minus 1, you know? It looks really confusing when you look at it. It's really intimidating. But I'll try to do my best simplifying this down, because really it's not the most complicated thing that you can do. So, in fact, it's quite easy, to be honest, because it's really just long division. There we go. So, we got 3w minus 2 divided by, and then for simplicity's sake, we're going to write in terms of, you know, the highest degree of our x, or our w in this case. So we'll write the 9w cubed first, because it's the highest. Then it would be plus 2w, and then minus 1. But there's one thing that we have to do to set this up in order to correctly divide it. And you see how we start off with, hold on one sec. We start off with a 3w, and then we go to w1, but there's something missing. We don't have a w squared in between these two. And in order to do it, we have to have a w squared. So we can't really just add in a w squared, so we're actually going to add in 0w squared. So to actually start off this one, you would have to write 3w squared, or sorry, 3w minus 2 divided by 9w cubed plus 0w squared plus 2w minus 1. So now how do we get started? So what we're actually going to do, we're going to be manipulating the first term from the divisor and the first term from the polynomial. So how many times does 3w go into 9w cubed? We know that will go in 3w squared times, because a 3w times a 3w squared, that will be 9w cubed. So since it's w squared, we're going to write that over top of the place that has the w squared. So this has a w squared, so I'm going to write this one over here. If let's say that, let's say that it multiplied, you know, 2w into our whatever term we were trying to get it to match up with, then we would write that over top of here, the 2w one, because it has a w. It has to line up exactly. So now that we have this, we know that 3w squared times 3w is 9w cubed. So we're going to subtract and make sure to put the brackets here. 9w cubed, and then we're going to do 3w squared, and then this time we're going to multiply that by a minus 2. So that will be minus 6w squared. Minus 6w squared. And put this all in brackets, and we're going to subtract. So we know this will be 0. Then a minus times a minus is a plus, so 0 plus 6 will be 6w squared. And then same, just like long division, we're going to bring down the 2w. So we have 6w squared plus 2w now. So how many times does 3w go into 6w squared? It goes in 2w times. So that'll be plus 2w. So 2w times 3w is 6w squared. And then 2w times minus 2 will be minus 4w. And then we can subtract these. This will be 0. And then minus times minus is plus. So 2 plus 4 is 6w. Now we got 6w minus 1. So now 3w minus 2, or just the 3w, will go into 6w just 2 times, right? So plus 2 on the top. And then we'll do minus 6w, and then positive 2 times negative 2 is minus 4. So now this will be 0, and negative 1 plus 4 will be 3. So we finished because we have nothing else now. 3w can't go into 3, so we're done. So that means that this will be our remainder right here. 3 will be the remainder. So really we could be done, and because we stay the remainder, we can just say r is 3. But just to take it to, the next level, we're going to write a division statement, and we're going to write a quotient statement. Or in quotient form. So the division statement, we know that one it's the x minus b, which is 3w squared. And this is times the quotient, and our quotient is the answer. And that's going to be 3w squared plus 2w plus 2 plus plus the remainder, which is 3, and that's going to equal the answer, or the polynomial, which is 9w cubed plus 2w minus 1. So that's our division statement. And now let's do one more, and let's do the division statement. Quotient form. So quotient form, we know, is the polynomial divided by the divisor. So 9w cubed plus 2w minus 1 divided by 3w minus 2. And then that's going to be equal to the quotient, which is 3w squared plus 2w plus 2. And then that's plus the remainder divided by the divisor. So that's going to be 3 divided by 3w minus 2. So it seems really confusing, right? Like, how can I remember something like this? But honestly, the easiest way to remember is just to do as many of these and just memorize it, because there's no way that someone's actually going to just remember this off the top of their head. Like, the only way that you're going to do this is just to memorize, what it looks like, and then how you can set it up every time. So now the really important part, basically the only important part of this video, is what is the remainder theorem. So the remainder theorem, it says that if you have a function of something like this, and it's divided by a divisor, the x value of the divisor, if you put that in, sub it in for all the x values, then that will equal the remainder. So it's basically saying that for this, x plus 2, if we equal that to 0, x will be equal to negative 2. So if we do f of negative 2, then that will be 2, negative 2 cubed, to the power of 4, minus 3, negative 2 squared, minus 5. F of negative 2 will equal the remainder. So instead of doing this one, I want to do the one that we just did, just to prove it, that it actually works. So we did 3w squared and 9w cubed plus 2w minus 1. Okay, hopefully I can remember that. We've got 3. Oh, I already forgot. Hold on, let me look at my sheet. Okay, so It's divided by 3w minus 2. This is our divisor. So our divisor, w will equal 2 over 3. If we equal that to 0 and isolate for w, that's what it will be. And then we've got 9w cubed plus 2w minus 1. So if we were to do this, f of 2 over 3 equals 9, 2 over 3 cubed plus 2, 2 over 3 minus 1, f of 2 over 3 will be equal to, and then, hold on, let me bring up this calculator real quick. So this will be equal to 9 bracket 2 over 3 bracket to the power of 3 plus 2 divided by 3 minus 1 will be equal to 3. Now if we look back to our other slide, the remainder was indeed 3. Right here. So really it's just a shortcut, the remainder theorem. Just remember that if you're dividing something by a polynomial and it suddenly asks you for the remainder, instead of doing the entire long division process, just simply look at what the divisor is, equal that to whatever it is, you know, w or x or whatever your variable is, plug that in as whatever as like the function of that, and then that will equal the remainder.